In this webcast, I'm going to explore how we can use image tags for faceting and filtering images using Azure Cognitive Search. This webcast is a continuation from part 1, where I looked at creating a dataset of photos and then creating an index for those photos using Azure Cognitive Search. I'll be publishing more webcasts in this series, so please subscribe if you'd like to receive updates. So let's take a quick look through the resources that I'm working with in this scenario. It's basically a continuation from the previous webcast, when I generated the photographs index with captions, tags, and celebrity identification. I've got a resource group called Cognitive Search Webcasts, and in that resource group, I've got an instance of Cognitive Services, I've got a storage account, and an instance of Azure Cognitive Search. In the storage account, I've created a container called Photos, and this is where I've uploaded all of the images that I've indexed. And these are the images that I've indexed in search. 814 images that I got from Googling for random photo. In the Azure Search service, I've created a data source pointing at that blob container. I then defined a skill set that can be used to analyze the images and generate the captions, tags, and celebrities. We have an indexer process that's used to create the index. And the index itself that you can see contains 814 documents. And you can see in the fields that image tags, image captions, and image celebrities are selected as retrievable, filterable, facetable, and searchable. And I've demonstrated how I created that index and all of those resources in the previous webcast. So let's explore how we can work with tags. The portal provides a search explorer that allows us to enter queries and see the results. So if I enter cat as a query string, we can see the search results coming back in JSON. And the Cognitive Services has generated tags for each image. The tags for this one are text, animal, funny, mammal, and carnival. Scrolling to the next image, we can see that this one was tagged as a cat. And the next image was also tagged as a cat. So when I do a free text search, it could pick up that cat was used in OCR text, or it was present in the caption image. Supposing I want to use filtering and search for all of the images that did contain cat as an image tag. I'm going to enter $filter to specify that we're using a filter. And that filter is going to be using the image tags property. Now each image can have multiple tags. So here I'm going to use an expression to say that we want to be searching for images where any of the tags for the image is equal to cat. So I'll press enter to execute that query. And you can see that the image tag collections for all of the images retrieved contains the image tag of cat. We've also got cute appearing as one of the tags. So I can modify the query to search for all of the images that were tagged as cute. The metadata storage path for these images is base64 encoding. So instead of copying the URL, decoding it and pasting it into the browser, I'm going to jump to the Visual Studio project, which I've modified to work with tagged searches, and will also display all of the results. So let's look at how this is implemented. After I've initialized a search client, I'm generating a new search options object. I'm setting include total count to true, so we can see how many images are being retrieved. I'm then adding image tags as a facet, with a maximum count of 50, which means that when the search results are returned, we'll also get up to 50 tags from all of the images that were returned within the search results, and these can be displayed in the browser. If we've got a tag within the query string, we're going to add a filter to the search options, and we're going to be using the same syntax as I used in the Search Explorer. We can then use a search client to perform the search and retrieve and process the results. So let's see how that implementation works. So I'm going to browse to the image search page and search for cat. And you can see that that search has retrieved 56 results. We've also got a number of tags populated down the left-hand side of the page. So let's click on the cat tag. And you can see that 17 images have actually been tagged with cat. The first image looks like somebody's photoshopped a cat on a bear and a cat on a hedgehog. And that does seem to be confusing Cognitive Services. If we scroll down, we've got quite a lot of animals. And the green goblin thing sitting on the rabbit also seems to be causing some confusion. But quite a lot of these images do appear to be cats. So let's click on cute and search for the cute images. We've got 7 results here, and most of those do appear to be cute. I can click on Funny, and it's showing images that Cognitive Services has classified as funny. If I click on Ape, we've just got the one image returned that does contain an ape. I can click Mammal. Here we've got 53 results. And click on Toy. We've got 20 images here, most of which do contain toys. So you can see these tags do seem to be very accurate. When I search for balloon, I do get a photo that contains balloons. Others less so. These 3 images have been tagged as playground. And these 3 here tagged with Christmas tree. Cognitive Services, out of the box, will provide great capabilities for tagging image libraries. It's not going to be 100% accurate, but right now the service seems to be pretty good. And bear in mind that the service is improving all of the time. So if I was to re-index these images progressively on a monthly basis, it's likely that the tagging accuracy would be improving over time.